Hi, and welcome to Temeko. In this video, we will look at how the equilibrium of a particle can be obtained. We will also discuss how to solve coplanar force equilibrium problems for a particle. Let's get started. If you remember the lecture in which we went through Newton's laws of motion, you may recall Newton's first law, which dictates that a particle stays at a rest position or continues in steady motion with a constant speed if there is no external force or the resultant of all external forces applied on the particle are zero. So as you can see, the equilibrium of a particle can be maintained in these types of situations. Nice. However, usually, when we are talking about the static equilibrium of a particle, we are specifically referring to the case where a particle remains at a rest position. This condition may be stated mathematically as summation of F equals 0, where the resultant force vector summation of F is the vector addition of all the forces acting on the particle. This equation works for us as a sufficient condition for obtaining the equilibrium of a particle. In most cases, when we want to apply this equation of equilibrium, we must take into account all the forces that are subjected to the particle. These forces are usually a combination of known and unknown forces. Now that we have discussed in which conditions the equilibrium of a particle can be obtained, let's move on to observing the coplanar force system that is acting on the particle which is in an equilibrium state. If we have different coplanar forces which lie on a two-dimensional plane xy, then we can resolve these forces into their I and j components. In this case, we can write our equilibrium equation as follows. Summation of F equals 0. Summation of Fxi plus summation of Fyj equals 0. For obtaining the equilibrium of a particle, both the x and y components must be 0. Therefore, we can write summation of Fx equals 0, summation of Fy equals 0. Usually, when we are applying these equations, we will use a scalar notation for representing these vector components. By using a scalar notation, we are indicating the algebraic sign for the component, which can either be positive or negative, depending on which direction the component is pointing at on its corresponding axis. Let us now summarize the procedure for solving coplanar force equilibrium problems for a particle. The first thing that you should always do is draw the free body diagram of the particle. In this step, you will establish the positive directions for the x and y axis, and you will draw each known and unknown force with their magnitudes and directions on the diagram. After you have drawn the free body diagram, you can start applying the equations of equilibrium which are shown. Just remember that if the magnitude of the force component is positive, then it is directed along a positive axis and vice versa. One additional thing should be mentioned. If you are solving an unknown magnitude of the force and the solution yields a negative result, then this means that the force was labeled with wrong direction on the free body diagram, and the direction should be reversed. And that's it. That is the procedure in a nutshell. Hopefully after watching this video, you know in which conditions the equilibrium of a particle can be obtained. You also know how to resolve coplanar forces which are acting on a particle into their rightful components. Finally, you know the steps for solving coplanar force equilibrium problems. Thank you for watching and have a nice day.